What's up, guys? Today I'm going to show you my solution for terrestrial drone. This is not a good or optimal solution. It is just so ridiculous that I feel like I have to show it. Yeah, pretty crazy. So in this one, I kind of dug myself into a hole and made some bad decisions early on. And instead of scrapping it and taking what I learned and redesigning it, I was really stubborn and wanted to get it to work. I eventually did, but yeah, this is spaghetti, so we'll explain how it works. So this is the output we want. 2 treads, this little tower, thing in the back, and then the gun. So I started with this little brown tower, so you can see it's 3 and then 2. And so I started on that input, and this is at +1 input rate. And so I did this little thing, so it makes 2, the next one comes in and makes 2, and then this one is going to push it away. And I did at first try and make it so this one would be the 5th one and somehow get some here, but this one actually becomes part of the next 2x2 square, and the 5th one that gets added onto this 2x2 is actually right here. Now see, this is going to trigger the sensor once it gets pushed away and push it off. And then this 2x2 fell down, fell into here, and then that one's going to fall in, trigger the sensor, and get pushed. So that little tower is done. And it has to get rotated to fit, to be aligned properly. So just rotate it twice and slide it into our little assembly. Now let's look at how the treads get made. So I let them all come out, and then I just sense it and do some pushes. And so there's one interesting thing to note. You'll note by this selection, this is a tread of 4, and then a single, and then another tread of 4 and a single. And I'll explain why that is in just a second. So you can watch the treads, they both just fall down, get rotated, and then kind of slide into position. So you can see they fall in here, right where this thing gets welded to both of them. And the reason I had to do 4 and 1 is because at first I did do 5 treads in a row, but imagine these are not here, these 2 blocks, and there's treads there. It's impossible to actually fuse this to the treads, because you need the surfaces to be flush for 2 blocks, and you can't fuse on the bottom. If you could fuse on the bottom, it would work, but really the only realistic way I could fuse them was these 3 back here that I've done. So I realized, okay, I have to do 4 treads of 4 and then use the extra ones that eventually come along and get fused at the very end. And so that was the thing that I wish I had known from the start that would happen. But you know, I adjusted and got it working. So now we'll also follow the one that gets put in the back. So this one's really boring. It just delays for a long time, and then it gets timed out, so it falls right in, right as this gets here, and then gets secured. And the log is pretty much the same thing, the log which becomes the barrel. You can see how 3 are going to get fused, then pushed, and then rotated, and then it just stalls for a while, stalls, and then falls in. And so, yeah, this is pretty hectic. There's conveyor belts everywhere. But the real thing that I thought I was pretty proud of this was with these last 2, with these individual ones. So maybe you can see the issue. We will see this falls down and gets rotated. The single one has to be rotated too to get fused here. Yeah, you can see this is aligned this way, and this one is aligned this way. So you can see the tread is pointing towards my camera. This tread is pointing perpendicular. So I have to rotate these single blocks. Now, rotating a single block is not hard. You just use a little rotator. But then how do you get it off the rotator? You can't have a pusher and a sensor, because if they're next to this, if there's a pusher right where I am right here, the block actually won't rotate because it needs some free space to do the rotation. So that's no good. So really the only way to do it, one of the only ways, is to have it rotate and then have the next one come along and push it off. But that would take way too long, and this is a hectic level. I need these to get pushed along their way. So I came up with kind of a ridiculous solution. It's this little contraption. It's the same thing on both sides. But as you can see, there's a little lifter here, and then a pusher and sensor. And this pusher and sensor are not connected to, well, when the level starts, they're not connected to anything. See, they're free floating. So when I start, well, it would fall down if the blocker wasn't here. See, I'll get rid of the blocker. It falls. See? See, this is what it does. It comes up. There's a sensor here. If there's, you know, I might not actually need the blocker now that I think about it. See, it comes up after it's rotated, and then it pushes it. This sensor sees it and pushes it. This sensor sees this thing and pushes the whole structure. Luckily, the priority worked out, so this push happens first, and then, then on the next frame, or the next cycle. So this push happens, and this one can't push, I guess, just because the way the physics are programmed, you can't have opposing pushes in the same cycle. But once that one's done, this one pushes it, and then it falls back and keeps doing this again. I think the blocker might be important to, well, let's try getting rid of both blockers. The reason I had the blocker was just to time it out, and I had it so this didn't fall down, didn't start until the tread had reached a certain point. But that actually might be unnecessary, and it kind of looks cooler with it flying around everywhere. So let's see if this solves it, and if it does, then I'll keep it. Looks good to me. Nothing's clogging up. I'm just gonna make sure it actually solves it. Alright, cool. That means I can get rid of these sensors. That actually makes this a lot less hectic. Let's see. Something needs to support this though, so. Alright, so I'm going to assume that still works. That one looks to work. So, oh wait, no, that's what I wanted. Yeah, so you can see it rotates, and then luckily it didn't time out. If the timing was that this was right here when it slid in, then it wouldn't allow it to rotate, and then it wouldn't work. But luckily the timing works out. So now the things are rotated. This one just falls down here. This one falls down here. And then let's see what happens. So you've seen the main kind of chassis come together. And then when this tread hits this sensor, it's going to push the chassis out by this gun, the gun right here. So you can see this is going to go into the sensor, and then this pusher is going to go off. And that pushes it onto this treadmill, so it slides it along, and then pushes it back where this is waiting to get fused. And let's see. I'm trying to think. Oh, okay. It's just timed right. Okay, yeah. There wasn't anything about the fuse that triggered it to keep going. That was just this treadmill right here. So yeah, this is just sitting here, and this comes along, just happens to hit this and fuse, and then it gets pushed here. And the timing works out just perfectly that this one is falling right on here. So this will stay stationary until this one fuses in, and then the treadmill pushes it. And then it gets pushed along, and there you go. So yeah, this one is crazy. It's just a lot of... Instead of using pushers and blockers to time things, I kind of just ran lots of treadmills to time things. And this is one of my first like times really using freestanding blocks like this. I've seen some videos of solutions that have stuff like this, but I was pretty proud of this one. I was starting to think it wouldn't be possible. Well, it's never impossible, but I was starting to think I wouldn't be able to solve it once I realized I had to rotate these individual blocks. But yeah, I got it working. It just looks ridiculous, and you can see on the histogram how bad my score is relatively. The cycle score is actually not bad because I did have a high input rate, but the block score and the footprint score is pretty bad. The block score is bonkers. It's not as bad since I just got rid of those unnecessary blockers, but still pretty bad. That would be cool to see the 100 or so block solution. Well, yeah, hope you enjoyed the video and the explanation. Thank you for watching.